All right. Hello, everybody. Welcome to Unite and welcome to Barcelona. Or if you're watching on the recording, hello from Barcelona. Let's get into it. So today we're going to talk about immersive experiences, building cross-platform mixed reality. And hello, my name is Andy Biar. I'm a senior software engineer on the Unity XR team. I'm the technical lead for the AR Foundation family of packages.
Hey, Matt Schoen here, staff software engineer on the Spatial team, and I work on Spatial and Vision OS support.
All right, so today we're going to talk about XR development with Unity 6. We're going to talk about the state of mixed reality and the packages that go into that, and then Matt is going to take over and talk about the VR multiplayer template and some Apple Vision OS updates. So let's get started. First, a sort of overview of XR development with Unity 6. On the Unity XR team, we are dedicated to helping you maximize player reach by helping you target as many platforms as possible across leading XR devices. And this is built into our architecture. So when you build an XR app for Unity, your app code depends on the Unity XR layer, which contains all these different packages that enable XR support. And then openly extensible, Unity provides XR provider plugins that depend on Unity's XR layer and surface data up in a cross-platform way, but also anyone else, any SDK developer can add support for AR Foundation or other mixed reality packages by implementing a provider plugin for the XR layer. And so what's really great about that is, say a new XR platform comes online, your app code doesn't need to change to support the base mixed reality features on that platform. And mixed reality has been a big theme this year in XR development. Whether you currently have a virtual reality app or a mobile AR app, or you're starting from scratch and you're looking to take advantage of new mixed reality capabilities on different devices, Unity 6 has the latest and greatest tools to help you get there. Whether that's supporting mixed reality pass-through on devices like Vision OS and Quest 3, or targeting Apple's Vision OS shared space. So we'll cover both of those topics today. A great way to get started is with templates. So I've included this GIF here just in case you don't know where to find them. In Unity Hub, under the Create Project menu, we've got 4 XR templates in there that have all been updated for Unity 6. The mixed reality template, VR and VR multiplayer, as well as mobile AR templates to help you get off the ground running in this new Unity Engine version. And lastly, if you are new to Unity or XR, we have this great ebook that just came out. Is also sort of mentioned in the keynote earlier. There's a lot of great educational resources for Unity 6. This one, called Create Virtual and Mixed Reality Experiences in Unity, includes a step-by-step walkthrough of how to set up a project, how to configure your XRI interactables, Vision OS project setup. It's a great resource, as well as sort of introductions to other areas of Unity as well, from baking, lighting, and other things like that if you're unfamiliar. So check that out at unity.com/how-to. And now let's get into the state of mixed reality in Unity 6. So today we're going to take a brief look at the mixed reality template. It contains 3 packages primarily: XR Interaction Toolkit, XR Hands, and AR Foundation, and combines the capabilities of these packages to deliver one cohesive mixed reality experience of just sort of, in this case, simply placing an object and manipulating it in physical space. And so let's talk about each package individually, and then we're going to do a live demo. So XR Interaction Toolkit, available now in Unity 6 Preview, is XRI 3. One of the key features of XRI 3 is the near-far interactor, which combines the capabilities of what used to require several different components previously. So if I can just sort of explain what you're looking at in this animation here. We have an interaction that starts with a ray cast from one hand, drags the object around, brings it closer, then becomes a grab interaction on that one hand, then becomes a two-handed interaction, then back to one hand, and then throwing the object. All of that powered through the single near-far interactor, where before you would have had to have a ray interactor and a grab interactor and manage all the interaction states between those things to enable and disable the different interaction modes. So we're really excited about XRI3 to sort of smooth out that interaction process. And XRI3 also has input readers, which is a big refactor of how XRI handles input. So if you're using XRI2 today, there are some component changes, and definitely check out the upgrade guide to understand more about those. But this refactor is really nice for modularity, scalability, and better support for the VisionOS shared space. So it's a really exciting sort of low-level input change. And lastly, some of the best innovations are the simple ones. And XRI3 also contains a keyboard sample, which lets you, it demonstrates cross-platform text input on different XR devices. So if summoning native keyboards isn't how you want your app to work, you want to have one consistent keyboard UI across your different form factors, check out the keyboard sample as well. The XR Hands package, we have version 1.4 in Unity 6 preview right now. The big story there is custom hand gestures and a gesture debugger. So here, my left hand is primarily in view, and you can see there are different states on the left that are tracking each of my fingers and each of the finger joints. And so as I make the forward pointing gesture with my left hand, you can see all 5 of my fingers are entering a zone of detection for a finger point gesture. And so this sort of debugging experience can help you set up your own custom gestures using the XR Hands package. And AR Foundation, my baby, is also in Unity 6. We have AR Foundation 6, which is exclusive to Unity 6 and above, and we're going to talk a bit more about the exciting capabilities that we have by depending on Unity 6. But for starters, let's just talk about bounding boxes, which is a new subsystem that enables us to surface 3D object data supported by runtimes like Meta Quest, where in the space setup, if you set up beds and couches and different things, AR Foundation can learn about the 3D objects in your room and their classifications and report that data to you in real time without needing a pre-compiled object library like how ARKit currently works. And there's also persistent anchors, which is a feature that we're very excited about. We have a cross-platform API there that is currently supported on MetaQuest, with support for more platforms coming in the future. But the key concept there is to place an anchor somewhere, have an experience on that anchor, such as on the top of a table if you want to save the placement of a game mat. Save the position of that anchor, then you can quit your app, go to bed, come back the next day, and bring back the state of your app spatially at that same position. So save an anchor in one session, then load it in the next session, as well as erase it if you want. And lastly, image stabilization, which stabilizes shaky video from the camera, which is currently supported on AR Core. So all of this available now in Unity 6 preview. Go and check those things out today. I also want to add that as we support more features in AR Foundation, the platform support matrix is necessarily becoming more complicated. So definitely check out our docs. Feel free to take a picture of this. It's also available if you Google AR Foundation. It's the first thing you'll see on the front page. We have a wonderful technical writing team that is helping us sort of bring AR Foundation into the future with lots of docs improvements that have gone in already and more to come. And lastly, I want to call out Unity OpenXR Meta. This is our AR Foundation provider for MetaQuest. It's built on top of Unity's OpenXR plugin, and it delivers mixed reality data through AR Foundation's cross-platform abstractions. So if you already had an app that used pass-through or plane detection on ARKit or AR Core, all those things work the same way when porting to MetaQuest, and we're excited to sort of continue that pattern moving forward with other mixed reality devices as well. This package also supports platform-specific features for MetaQuest through OpenXR extensions. So if you're starting a new project targeting MetaQuest, we definitely recommend that you check out OpenXR, see if our OpenXR support covers everything that you're looking for. And also, let's talk about what's inside there. So bounding boxes and persistent anchors we already talked about. And then in this example, I'm also showing meshing. which again comes up through the same meshing subsystem that we're using on on ARKit and Vision OS. So your app doesn't need platform-specific code to utilize the room mesh. And now let's do a live demo. These always work. Okay, great. So I'm booting into Quest Link here now with a slightly modified version of the mixed reality template. And okay, already we can see there's some example components here that you can take advantage of. We have this lazy following UI, so as I move my gaze, this UI sort of comfortably follows me in my view. We're gonna skip that. We've got a nice video player here, we'll skip that. And let's talk about what you don't see, which is pass-through. So in the headset, I can see you all right now, hello out there, but on the Meta Quest runtime, applications don't have access, CPU access to the pass-through pixels. They're injected directly into the compositor, so you won't see pass-through over link, but I promise you it is working. And with that, what else should we talk about? So let's see. As I'm looking around, you can see you're using Air Foundation for plane detection. And as I interact with the surface of a plane, I can spawn objects and then grab them, move them around. This is all through XR Interaction Toolkit. And that is the general basics of just sort of, getting pass-through plane detection and interaction into one project. The last thing I want to show off is hand interaction, and as I set these controllers down, they will spawn more objects. But we also support switching between controller input and hand input in real time. So now I've switched to hand interaction, and you can see also in here is a hand local UI menu that I can interact with. Anyway, yeah. So let's switch back to the presentation there. I think the issue there is, might have been, I think hand interaction on Quest Link is a little bit less sensitive than in a build, but those buttons do work. Okay, where is this? Great. So that's sort of the state of mixed reality in Unity 6 today. But I'm an engineer, so let's talk about some code. Air Foundation introduces a new API in Air Foundation 6 for persistent anchors, and along with this, we're also introducing a new paradigm for Air Foundation using the async await keywords in C#. And we have a couple different asynchronous programming patterns in Air Foundation, and I'm excited to share that async await is the way moving forward, powered by the new awaitable class introduced in Unity 6. So over time, we're going to be doing a lot more async await awaitable, and we have documentation up there, up already live now that sort of talks about how to get through those programming patterns along with sample code. So taking a look at this API, we take an AR anchor as input, we save it to an unspecified location. That's our try-save anchor async. So if it's up to the device implementer as to whether that's saved locally or perhaps in a cloud storage somewhere. Air Foundation has no opinion. And we return a GUID associated with the storage. So you save an anchor, you get a GUID back, you pass that GUID into load anchor, and you get an anchor back. And then you pass that GUID into erase, and you get a Boolean that says, yes, I erased it. This API also takes a cancellation token. Note that the MetaQuest runtime does not support async cancellation, but future platforms that we will be supporting do. So this cancellation token is optional, and on platforms that support it, will allow you to cancel the async operations in progress. On platforms that don't support it, if you try to cancel them, the token will be ignored. So again, async await syntax, and awaitable is like task, but optimized for Unity with pooled allocations and synchronous continuation. So Real quick, what does that mean? Pooled allocations, normally C# tasks, when you create them, they are little state machines that incur heap allocations every time you create them, which is obviously really bad for game development where we need to keep our frame rate high. So awaitables are, under the hood, there's an object pool of them, so you can keep using async awaitable APIs without incurring new allocations. And synchronous continuations. So normally when a task completes, it posts to the synchronization context, which in Unity causes 1 frame of delay between the task completing and you, anything awaiting the task being notified that the task completed. So with synchronous continuation, you get faster response time. And yeah, Air Foundation is an early adopter of the awaitable class in Unity 6, and we are really excited with what we're seeing with it so far. We also support platform-specific error codes. So here's some sample code that uses that persistent anchor API. Await manager.trySaveAnchor async. We pass our anchor in. We get a result back that contains a status and a value. We check that status. If that status is an error, don't read the value. Otherwise, you're good to go. And if your app cares about platform-specific error information, we are also surfacing platform-specific error codes to you so that you don't need to ask your customers to send you their log files to figure out what is going on their device. So in this case, we see status code is platform error, and Air Foundation doesn't depend on OpenXR, so Air Foundation doesn't know the type of the native status code, but in this case, I know that I'm running on an OpenXR runtime, so I'm going to cast my native status code to XR result, and then I can access my native error information that way. And lastly, I want to talk about some upcoming releases, because even though everything I've just shared with you so far is already available in Unity 6 preview, we have even more content coming before Unity 6 is fully released. So Air Foundation 6.1 is in pre-release now. This is exciting. And it supports simulation bounding boxes and AirCore Vulkan pass-through. So simulation bounding boxes shown here, very similar to the bounding box functionality that I just showed you on MetaQuest. But this is especially useful if you are developing for MetaQuest on a Mac where you don't have access to Quest Link. You can just run your app in the editor and see bounding boxes appearing for your simulated spaces. You could also potentially build some automated testing on top of something like this. And AirCore Vulkan pass-through. I've been answering questions on the forums about this for a year, so I'm very excited to share that Vulkan is working on AirCore. Pass-through is in pre-release now. You can install it by going to the package manager and typing this in, com.unity.xr.airfoundation 6.1.0-pre.1. And in future versions of Air Foundation, we are looking to completely support the AirCore Vulkan suite with environment probes and occlusion as well. Unity OpenXR Meta 2.1 is coming soon to Unity 6 as well. And in this video, I'm showing our boundary visibility capability built on top of Meta's OpenXR runtime. So I don't know if you're like me, if you've ever stepped outside your boundary and have your app disappear and get this warning about, please stay inside your boundary. The new boundary visibility capability is a wonderful quality of life improvement to enable you to just walk around freely in pass-through without the app having to respect Meta's boundary. This is also available at the system level on new versions of Meta's system software, but with this capability, your app can enable this so that you don't have to tell your user to go into settings and figure out how to do all that. We also support Quest Link, which I just showed you, actually. This is my sneaky little demo within a demo. So Meta OpenXR 2.1 finally supporting Quest Link, so you can just iterate even faster on your experiences as you're building in Unity 6. And we're also going to support occlusion through Air Foundation's occlusion subsystem and persistent anchors batch operations, which will let you save, load, and erase batches of anchors at once. So you can imagine you're walking from room to room. Each room contains different anchors that you might care about. You can save and load those batches through that upcoming API. So we're excited to bring that to you soon. The pre-release will be even sooner, but I don't have any specific dates to share. And lastly, we have a new package coming out that I want to talk about. This is XR Composition Layers, our 1.0 version, coming soon to Unity 6. It's in pre-release now, and this is a great improvement for text rendering and other sorts of content, like 2D content to be composited into an app. So I want to focus on this GIF here because this is so critical. On the right, you have a UI image that's being composited through a compositor layer. On the left, you have an image that's just going through Unity's normal rendering pipeline. And as you can see, submitting the pixels directly to the compositor gives the really nice, sharp visual clarity, which is going to be great for images, UI, splash screens. It also supports 360 video, and really anything you can put on a canvas in Unity, you can put on a composition layer and get that nice visual clarity. Another use case that might come up is if you're using foveated rendering in your Unity layer, but you always want to keep your UI really crisp. Again, put your UI on a composition layer, and your composition layer will not incur the foveated rendering loss of detail. It also supports secure content. So I mentioned MetaQuest pass-through already. Again, application doesn't have CPU access to the pixels, but you can tell Unity, hey, this is the layer where I want pass-through to render, and these are the things that I want to render behind or in front of that. And you can customize that through that workflow, which I'll get into in a moment. And lastly, it's extendable. So you can add custom layer types. In fact, MetaQuest pass-through is implemented as a custom layer type. So what are the different kinds of composition layers? I just showed you a quad. We also support cylinders for curved UI and equirect for 360 video or any other sort of inverted sphere content that you might want to render. We also support cubes for skyboxes, cube maps, and lastly, I want to talk about the projection layer. So in composition layers land, everything in Unity by default renders to what's called the default scene layer. So all your geometry gets flattened into a 2D image that is going to be rendered, and then you can render content either in front of that geometry or behind it, for instance, in the case of pass-through. But then if you want to have 3D geometry that's rendering in front of a composition layer that's blocking the rest of your scene, that's where projection comes in. So here, these controllers are highlighted in red. These are on a projection layer so that they can render in front of that 2D quad, which is itself rendering in front of the 3D scene in Unity. So lots of fun layer stacking. But we expect this to be a common use case for apps, either mixed reality or VR, where you have, pass through your scene layer, your UI layer, and then your projection rig for anything that's very close to the user and likely to render in front of any UI. MetaQuest pass-through in the upcoming Meta OpenXR 2.1 package, without any changes to your project, pass-through gets rendered as a composition layer. And real quick, I want to introduce the new composition layers editor window. It's pretty simple here. It just shows you the order that layers are rendered. Positive numbers are rendered on top of lower numbers. So in this case, the default scene layer, all our Unity geometry is rendered on layer 0, and our pass-through layer is rendered on layer -1, and we have our camera's clear flags, the alpha value set to 0, so again, we're allowing that pass-through to be rendered behind the geometry while still being composited correctly into the frame. So let's talk a little bit about actually using this package. So to create a layer, right-click in your hierarchy window, go to Create XR Composition Layers. All the layers that I talked about are there, including some additional prefabs, such as the quad layer UI panel and the cylinder layer UI panel. These prefabs include XRI interactables, so they come pre-set up to handle UI interactions that you might want to do. The composition layer component is what you get. So this game object is the output of creating a quad layer. So it has a composition layer component and a source textures component. Composition layer component, very simple. Enable it to render the composition layer, disable it to stop rendering the composition layer. And you can set the layer order there. If you click that Manage button next to the layer order, that will bring up the composition layers editor menu, or editor window that I just showed you, and you can configure the rest of your layer in the inspector there. And this package also comes with a sample scene. So in this sample, we're supporting all the composition layers in one scene. So it's a skybox cube map with an ecorrect grid, the default scene layer, again, video and then geometry in front of the default scene layer, and a quad as well. So when this package ships, you'll just go to the package manager. There's a samples tab. Go into samples. This is the composition layer sample, so you can download this and play with it on any device. And lastly, let's talk about where you can do this. So we're supporting the composition layers package in Unity 2022 LTS as well as Unity 6, both built-in render pipeline and universal render pipeline. And because it's built on top of OpenXR, all OpenXR runtimes supported out of the box. So we're really excited about that, and that wraps up my mixed reality talk. So I'm going to hand it over to Matt to talk about the VR multiplayer template and VisionOS.
Good job. Alrighty, thanks, Andy. That was a lot to take in, so I'm going to give you guys a second to digest. But transitioning over to the VR multiplayer template, as you may have seen in the keynote earlier, multiplayer is one of the core focuses for Unity 6, and we have a ton of sort of new-ish, or at least finally a kind of comprehensive set of first-party tools and packages that we can leverage to create something like the VR multiplayer template. So I don't need to tell you that multiplayer is a very powerful tool. A lot of the most popular VR experiences, like VR Chat and Rec Room, use multiplayer to create these virtual worlds where people can hang out, interact, maybe play a little bit. And I'm sure a lot of you are aware of Gorilla Tag, which was sort of this almost overnight success, probably majorly due to the network effect created by it being a multiplayer experience, having this voice chat and all that sort of, all those fun things. So let's get into the details. So first and foremost, we want our templates to be simple and easy to use. You get everything from one click out of the hub. As Andy was showing you, there are sort of a couple options there. You create a new project, and it's all there ready to go. As I mentioned as well, it's using our suite of connected game services, and there are no third-party extensions. Everything comes from Unity, is managed by your identity through Unity login, and we leverage services like Lobby, Authentication, Relay, and Vivox to sort of create this end-to-end experience. Naturally, since these are different services, and also we have sort of XR-specific needs, the template includes any of the glue code that will sort of communicate and integrate these packages and services, but it's also relatively extensible and sort of easy to kind of pull apart and put back together with a little bit of code modification, of course, but like I personally have had the experience of sort of like trying to swap in a different package and was pleasantly surprised that there wasn't like 1,000 errors when I went and deleted one of the packages. It's also set up to be used as a foundation, not just an example. So a lot of the feedback that we've gotten from some of our templates and samples is like, this is great, but like, you know, it's all very bespoke, or it's too simplistic for me to actually build anything on top of. So we really had in mind the idea that you'd want to take this template and hopefully not just ship it as is, but use it as the foundation for a real production application or game. And also it sort of demonstrates some of the best practices that we've learned. Personally, I'm kind of excited about this because, you know, my journey at Unity started with Editor XR and sort of building out XR UX. And a lot of the learnings and sort of innovations that we built in the labs team and sort of across a lot of these XR experiences have landed in not just the VR multiplayer template, but the MR template that Andy was just showing off, and kind of our latest offering of, you know, the state-of-the-art, cutting edge. This is how you put a Unity project together for VR. So looking at some of the individual features, avatars. Sorry, first off, I wanted to mention again, sort of drive the point home that this is all cross-platform. So we don't actually use any platform-specific APIs. It's built on top of the OpenXR provider. We use the spatial keyboard that Andy mentioned, as well as our avatar system, Again, it's swappable, so if you wanted to use a proprietary avatar system as an option, totally up to you. But we also wanted to make sure that we provided a fully fledged, usable, production-ready avatar system from day one. It includes a couple different features. So as you can see in this GIF here, there are these name tags that sort of appear over your head. When you're close up, you get an initial, a full name, and like a audio status indicator to show if that person's trying to speak. As they move farther away from you, it kind of, like a LOD, level of detail transition, it turns down to just that little icon with the initials. And again, these are customizable. If you wanted to do icons instead of initials, that's totally easy to do. But it just sort of gives you this foundation upon which you can have like just ready to go avatars or build in your own art, build in your own kind of unique look and feel. And also, as you can see in some of these GIFs, we network the hand interactions as well. So if your players have controllers, you'll get these sort of like, grip flex that you're all familiar with, and if they are on a platform that supports full skeletal hand tracking, that will also be replicated over the network. We also use the XR Interaction Toolkit, aka XRI. So we built some extra extensions to the XR Interaction Toolkit for networking. So as you can see here, Javier there is manipulating a 3D object with his hands. That's driven by XRI and is essentially we've added the extra code needed to synchronize that across the network, both so that you can see the interactions that other users are doing and mitigate some of these issues of like, we both try to grab the same object at the same time, what happens? And again, these are all customizable and built for extensibility so that these are kind of a starting point for your bespoke application-specific interactions, but as you can see here, they're pretty robust to begin with. Moving on, so we're leveraging the lobby multiplayer connected game service that you may be familiar with from just Unity's general offering. And we've used that to implement lobbies in the multiplayer template. So when you first join, you're presented with a list of rooms. You can create a room. The rooms are identified by their name. And so we can all get together in a room called the hub, and we say, on Slack or somewhere else, say, hey, join me in the hub, and you can log into this session and see all your friends together. We've implemented a number of mini games, both as sort of dog fooding and examples, but also sort of demonstrating some of the different aspects of a game that you might want to put in sort of like a VR chat type world. So each game has a station in the hub world where you can kind of get people together. Say that the game requires 4 players, it will wait until 4 people have gone and activated the start game button. Some of them have timers or scoreboards, all those sort of generic features that like a little mini game might have. So the 3 that we have implemented are a climbing mini game, which also demonstrates some of those climb interactors for XRI, Whack-A-Pig or Whack-A-Mole, I don't know if that's copyrighted or something, but we call it Whack-A-Pig. And then another sort of like slingshot accuracy mini game. As well, there are some non-game stations around the hub. So there's this music player where, again, if you're familiar with social VR experiences, one of the main sort of like attractions is you can all get together and like watch a movie together or listen to a song that's sort of like playing in the background. It's synchronized, everyone's hearing the same music, you can kind of like uns together. And another one is this object spawner, which you'll see in a second, I think. It's the sort of central area where, again, you saw the avatar manipulating that little triangle, and it's just sort of like a little playpen where you can grab objects and make little sculptures. It can be a lot of fun to sort of like turn it into this creative experience like blocks or tilt brush, if you remember those. And then finally, like just a group chat, a message board where you can type text messages to each other. And, again, just sort of the basics for what you might want in a VR multiplayer experience. Just some more to rattle off. We use Vivox for spatialized voice, or we've used Vivox for voice chat, and we've added some extra little nuances to make people who are far away more quiet. Unity kind of by default has this audio listener and audio source spatialization that we leverage. So someone who's talking to your left, you hear them to your left. I guess you're right. You can mute yourself, and also you can squelch or mute others. Squelch is a term that comes from radio communication, where if there's someone who's squawking that you don't want to hear, you can turn them down, both for sort of like anti-harassment and bullying, but also just maybe someone's got a a loud fan or something like that, you're often going to want to mute people. As well, the spatial keyboard. Many XR platforms provide a built-in keyboard, but we also wanted to provide an example and sort of a basis for implementing your own keyboard. Maybe you want it to look a certain way, or you're implementing on platforms that don't support the platform keyboard. As well as, again, just like general UX best practices. So these scroll views and buttons and tabs and hand-based, controller-based menus. There's a lot more to that than you might expect, given that we're sort of using flat screen UI concepts in these menus, but like where do they go, and how do you invoke them, and how do you kind of make them visible without being too in the user's face? So a lot of thought and effort has gone into kind of making this a seamless experience, and to the degree that it can be intuitive and natural, I think we've really nailed it there. And finally, I want to talk about some of the things that we learned from this and where we're going in the future. So one of the my personal sort of like favorite things about these templates and samples is that we get to dog food our own packages and features internally. So plenty of time and effort is spent on creating the OpenXR plugin and the XR interaction toolkit and the multiplayer services, and sometimes it's overlooked that okay, we've created this feature, and like, is it useful? Have you been able to actually build something around it? And this is a great example of, yeah, we built this thing, like I think it could be a game on Steam or something like that, maybe with a little bit of extra work, but either way, that we have the experience of trying to build on top of this technology. And from that, we've learned, for example, the spatial keyboard was something that we kind of like realized that we needed midway through the project. If you've ever done a multiplayer VR experience, the mute button is like the first thing that you realize that you need, because when you don't have it, it's just like chaos. And I had some other examples, but they're not coming to mind. So the other thing is that there is a MR multiplayer template on the way. So similar to what you saw in Andy's demo, where you're using pass-through and the world understanding features, we're working on creating a multiplayer version of that. We're also working on some netcode improvements, so things like distributed authority and host migration. Those might be kind of jargony terms for multiplayer, but essentially the way that it works right now is the person who creates the room is the host. They kind of own the experience, both in terms of the authoritative locations of objects and players, but also the actual sort of interconnectivity. So when the host leaves, party's over, everyone has to sort of find a new room. Host migration implies that when the host leaves, we find someone else in the room to become the host so that we don't interrupt the experience for everybody else as an option. Another sort of part of the roadmap for game services themselves and sort of things that we're going to attempt to leverage in the template is the ability to run a dedicated server. Right now, it's a sort of centralized host through Unity Game Services, as well as LAN and direct peer-to-peer. Again, different ways of connecting players as opposed to going through the centralized relay server. So that kind of concludes the VR multiplayer section, and now I want to talk about some of the new features for visionOS. In case you missed it, last June, Apple announced visionOS and Vision Pro, and Unity 22 LTS has been our mainline support version for visionOS 1. visionOS 2 just recently left its beta period, and Unity 6 and the 2.x version of the polyspatial and XR plugin packages are what you want to use for visionOS 2 features. So both in terms of visionOS 2 support as well as some sort of new features to our visionOS support in Unity, there's a lot to cover. A bit of chaos going over there on the right with those GIFs, but hopefully you can kind of get an idea of the variety of features and kind of capabilities that we're adding. The main event is visionOS 2 support, so pass-through is available to apps using metal rendering. As a bit of context, if you're not familiar, Unity apps traditionally have been able to pick one of two different paths. You can either use Reality Kit to leverage the shared space with volumes and sort of a more consistent look and feel with other applications, or you can use metal rendering as a sort of more traditional way of rendering your Unity scene through the GPU and graphics pipeline and all of the sort of Unity rendering features that you're familiar with. On visionOS 1, pass-through was not available in that path with metal rendering. It now is, and that really kind of opens the door for a lot of more seamless transitions between porting something that you've made for Quest over to Vision Pro. The hand tracking API now uses a prediction timing, so essentially that means that you get smoother, more responsive hand tracking compared to Vision OS 1. The hover states for reality kit objects, as you can see, there's a sort of this field of buttons over there. In Vision OS 1, you had limited capabilities for how to indicate that the user was looking at a particular affordance. Now there are many more options to visually kind of make it pop. Dynamic lighting, resizable volumes, again, the list goes on. And then going into some features that are not necessarily Vision OS 2 specific, but have been introduced in our 2.0 version of packages. Previously, you were limited to only one volume of Unity content in a shared space. Now you can have many. There is a new feature that we're pretty excited about called stereo render targets that kind of bridges the gap between this reality kit and metal rendering divide, where in a reality kit session space, you can render to a stereo render target, meaning Unity cameras can render to a surface, and that surface will appear different between the left and right eye to give you the stereo effect. So in the bottom there, you can see those are the content that's in the middle is all rendered with Unity, and we have various ways of presenting that in the shared space. Hybrid mode was a bit of a journey for me personally to implement. Previously, those two modes of reality kit and metal were a decision that you had to make before building your app. So essentially, once you had chosen one, you were stuck with it. If you were making a reality kit app, that app could not use the metal rendering capabilities and vice versa. With Polyspatial 2.0, you can now mix and match. So you can build one app that switches at runtime or even blends the two with a metal rendering background, sort of as the immersive view and polyspatial reality kit objects in a volume at the same time. So hybrid mode gives you the ability both to switch and combine metal rendering with reality kit. And also with Polyspatial 2.0, we're shipping support for dots entities and dots rendering, I think. Again, and along with many more features, I encourage you to go check out the documentation and the discussions forum where there's lots of active folks talking about the new features. So I really want to dig into a couple of the new features that I'm excited about. Again, I mentioned this metal pass-through capability that's introduced in Vision OS 2. It really gives you this ability to take advantage of the full rendering capabilities of Unity while still participating in this mixed reality, shiny new world. In order to enable it, you take the immersion style setting in the Vision OS plugin settings and set it to automatic or mixed. You can use the camera clear flags to turn off the skybox, and you want to make sure that the clear color on your camera has a 0 value in the alpha or some non-1 value so that the pass-through will shine through. As with MetaQuest, the application doesn't have access to the pass-through image, so you can't apply any post-processing or modifications to the pass-through, but you're still able to leverage things like post-processing and other rendering features on the Unity content itself. So the pass-through image is basically always the background of the frame buffer, and everything else just gets sort of blended in on top of that. We've also made a number of improvements to the play to device feature, which with any luck, we'll be able to do a demo of at the end of the talk. For those who aren't familiar with it, play to device is a feature built on top of Polyspatial that allows you to visualize and preview and interact with your Unity scene from play mode on the Vision Pro. So both in terms of getting a look and feel, as well as using the gaze and pinch interaction or any other sort of platform-specific capabilities, rather than having to build to the device and go through Xcode and sort of wait for that lengthy process. It's much like Quest Link or just sort of regular play mode. Press play, the objects appear, and you can preview the content. What we've added in Polyspatial 2.0 is a variety of improvements to the connection stability and sort of things, like limited Wi-Fi restrictions. We've added a new console window, so you can see the Unity console in mixed reality in a native Swift UI. We've added some progress bars and feedback to the loading experience, so it'll tell you if the connection failed. It'll give you a progress bar showing you how much data has been transferred, which you'll see later in the demo. And we've added the AR data that comes from the platform streaming back into the editor. So things like hand tracking and world understanding previously were something you still had to make a build to test, and now you're able to do that in the editor as well. And of course, with everything else in Polyspatial 2.0, it supports VisionOS 2. The multiple volume feature is another sort of often requested and highly sought after feature that we were not quite able to get past the bar for version 1, but we were able to get it in for version 2. The volume camera is the component in Unity that you use to interact with volumes in VisionOS. Simply add more of them to your scene, and you'll have multiple volumes. You can control what shows up inside the volume with culling masks and layers, similar to how you would use a camera to distinguish between a UI camera and a scene camera. Even if scene content physically overlaps in the Unity scene, you can sort of direct it to one or the other volumes, depending upon what layer it's in. And at the moment, at least, input is limited to one volume at a time. So when you gaze and pinch at objects within the volume, if you, for example, grab a cube and start dragging it around and look at volume 2 over here, the input for volume 2 won't do anything. I went over a ton of features. There's still a ton more. Like I said, I encourage you guys to go out to the VisionOS documentation. If you just search, if you Google Unity VisionOS support, you'll find it, as well as our discussion forum, which has lots of nice information for you there. Okay, so I too have a demo. We'll see how this goes. It's going to be a couple of steps to start this up, so please bear with me. All right. And now the moment of truth. Can I?
You need the HDMI cable, Matt?
I do not. I'm using the AirPlay thing.
Ooh, fancy.
Yeah. All right. All right. With any luck, you'll start to see what I see. Hey, all right. That was the crucial bit there. So, all right. As you see here, I am in the Vision Pro. I can see you. You can see me. I can see my laptop screen here on the virtual display, and I have the Play to Device app open. So this is Polyspatial Play to Device. It's available through TestFlight. You'll have to pick VisionOS 1 or VisionOS 2. There are two different TestFlight apps, and again, the discussions post with the release notes will kind of guide you through all of that. Once you have it up and running, you'll see here it's saying it's ready to connect, and it's showing me the IP address of the device. So I'm going to go over to the Unity editor. I'm going to go to Window, Polyspatial, Play to Device. I should mention, so this is a Unity 6 editor. I've opened up and imported the polyspatial samples, which you get from the package manager, and I have it open to the project launcher scene, which is like the main launcher scene. I've opened the Play to Device window. The first thing I want to do is enable Play to Device. I'm going to enter in the IP address of the device that I see over here, so 192. I hope I don't do a typo again, and please don't hack me. Yeah. 1.224. Cool. I'm also going to go and limit this FPS setting here. Essentially, this is a way of reducing the amount of bandwidth demand and kind of latency so that you're limiting the frame rate of the editor so it's not sending updates as frequently to the device, especially here on conference Wi-Fi and things. I want to make sure that I have enough headroom. All right, so without, I can't stall any longer, we're going to press play, and with any luck, nope. Okay, did I get that wrong? 1.224. Yep. Okay. Let me try force quitting that app, and we'll try one more time. Live demos, folks. I promise I tested this right before everyone showed up, and it worked just fine. Blah 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 blah. Yeah. All right. So you saw there. This is you just launch the app through the home store, through the home view, like anything else. All right. Still the same IP address. Let's do it. Hey, all right, cool. So, like I said, this progress bar that you see here is a new feature. It's showing you how much data has been transmitted for this first frame, which is usually kind of like the bolus of all of your textures and models and those sort of things. And now I have a live connection between this app running on the Vision Pro and the editor. So have it a round of applause, right? This is pretty cool, huh? Please clap. Okay, so as you can see, I can interact both in the headset and in the editor. So clicking on these buttons here does what it's supposed to do. And I can see the kind of like nice environment map and reflections that you get from Reality Kit, which aren't visible in the editor. So say that I'm like, actively working in this scene and I kind of want to make some edits. It's bothering me that this is overlapping, so just give me a sec. Go away. Okay, so say that I want to make some changes and I, for example, like, I want to see a nice, shiny reflection sphere. So I'm going to add the sphere to my scene here. I'm going to go over and scale it down a little bit because 1 meter by default does not work in XR. And I'm an engineer, so I like messing around in the inspector, but like as you can see as well, the scene view is still totally usable. I can scale it up and down like an artist too. So I said I wanted the sphere to be shiny. As we all know, you want a shiny sphere, you need to create a material. I'm going to call it shiny. If I can type. Up the metallic and smoothness to 100%, and then drop it on the sphere. And wouldn't you know, in the editor I see just sort of the default skybox, but here I get a really nice sort of environment map like you would see in other apps on Vision Pro. And again, it's totally interactive, it's totally kind of live. And if I was more creator, I would probably show you something cooler. But we've also shown this demo a couple of times already, so this is something that you've already seen. Let's go try something out that is brand new, which is this mixed reality scene. So the mixed reality scene has already been part of the samples, but the ability to actually test it on played device is brand new. So I should be seeing some hand tracking, but it's not showing up. I'm going to blame that on the Wi-Fi. But we see here we have the XR origin. I can go and kind of investigate like what are my trackable objects doing, where are they located, what are their transforms. You can sort of see it's being updated there live. Similar to before, if I want to do some like material editing, say that I want to make the meshes like way more transparent, right? It's like I don't see the meshes right now. Let's try and like bump it in a little bit more. Like say split the difference. So again, as you're seeing, like I'm updating these parameters live, and I can kind of like do look dev or tweaks and work with the editor, also in mixed reality. I do want to show that hand tracking, so I'm going to try one more. As you can see as well, I can sort of like enter and exit play mode, switch scenes. I was switching scenes at runtime before. I'm now switching scenes at edit time, and I'm pushing my luck trying to reconnect. But here we go. Okay. Oh, cool. Okay, so now you're seeing as well. The latency could be improved. I'm going to say that this is the Wi-Fi because, at home it looks a lot better. But, this type of interaction as well is something that you really couldn't get just out of the editor. And again, if I wanted to have some cool tentacle fingers or I don't know what, you could sort of still test that without making a full build. And lastly, as I mentioned, we have this SwiftUI console. I can hide my shame and suppress those errors for one. And also if I wanted to go and search for things like networking messages, these mixed reality spheres are getting in my way, but let's pretend that worked. So these are some of the new features of Play to Device that we're really sort of excited to be playing around with, and we hope that you guys are as excited as we are. With that, I'm going to head back to the presentation, and that is our time.